All right, here we're looking at an example from section 5.8, which is integration using tables. And the idea here is sometimes we have an integral that we can't solve using U substitution, we can't solve using parts, we can't solve using partial fractions or any of the other techniques that we've learned so far. Or maybe we could, but we just can't figure it out. So what do we do with it? Well, nowadays, one of the most common things to do is put it in to a computer, like Maple. And so that's why this section also has integration using computer algebra systems. But before we had such advanced technology, people didn't put it into Maple. Instead, they looked in tables of integrals. So there were books published with lists and lists and lists of the answers to complicated integrals. And most calculus textbooks have a couple of pages worth of those tables. And here over to the right of the screen, I've reprinted some of the basic formulas from the table in the back of our book. So integration using tables. Even though we do have computers now, it's still a valuable skill because you can't always carry Maple in your back pocket, and you could carry a short little list of these tables. All right, so what are we looking at here? We have our integral e to the x over 3 minus e to the 2x. When we're trying to use the tables, you might take a minute to flip through and notice that they're organized by the format of the thing you're trying to integrate. And so over here you can see I've got 17 has an a squared plus a u squared. Some of these have a squared minus u squared. Sometimes the u squared comes first. Sometimes there's a square root. In order to read any of this, you have to understand that the book uses a to represent a number, any number, and u is always used to represent a function. Of course, a number can be a function, but the function can be more complicated. It can have variables in it where the a can't. All right, so when we have a problem, our first step is to try to see which of the integration rules in the table is going to be most appropriate. This example that I've picked has kind of a classic, I might call it a trick, but it's not that hard of a trick in it, where this e to the 2x, you have to get comfortable with recognizing that this is really the same as e to the x squared, because if I have something to a power raised to another power, you multiply those powers together. All right, so e to the x, is that a number or a function? It's a function, so that's going to be my u squared in the formula. And then I'm also, in most of the formulas in the table, I'm going to need an a squared. Well, my number isn't really a perfect square. That's awkward. What is 3 the square of? Well, it's the square of the square root of 3. That wasn't so hard after all. Let me see if I can clean that up a little. Ugly. 3. There, that looks better. All right, so let me put my e to the x back on top. Dx at the end, always. All right, so in this problem, we go back over to our table and we think, which one of these applies? One thing I notice here is that I don't have a square root symbol at all, so I'm not going to be using 18. Another thing that's kind of critical is that I have a minus sign. That tells me I'm not going to be using 17. I also notice that the number comes first, that a squared comes before the u squared, and in a subtraction problem that really matters. If it were an addition problem we wouldn't care, but in subtraction order matters, so really 19 is the formula that I'm interested in, not 20. Okay, so over here in my problem, let's decide what the pieces are. My a in this problem is going to be square root of 3. My u is e to the x. And then I also need to figure out what's du, because that's a part of the formula. Du is, well, if u is e to the x, then du is e to the x dx. All right, so in this original up here, let's set it off and make sure we know that's kind of side work. In my problem, I have, I've got that this is the integral of, well, on the bottom, this is square root of 3 is my a squared minus e to the x is my u squared, and then all of this, all of that is my du, so I have du on top. And notice again, this is exactly the formula 19. So that is equal to my original problem, but it's formula 19 that tells us that this is equal to 1 over 2a natural log of u plus a divided by u minus a plus c. All right, so writing this 19 above the equal sign, this is an important part of showing your work, telling us which table value you used, which formula you used. Okay, and now all we have to do is go back and plug in the u's and the a's to get the answer. This is the answer. 1 over 2a, well, a is the square root of 3, natural log, absolute value, u, e to the x, plus a, square root of 3, divided by u, e to the x, minus a, plus c, because we've got an indefinite integral. All right, and that's it. This is your answer. There you go. Thanks. Hope that helped.